All right, welcome everybody. Welcome to our presentation on Introduction to Pandas. My name is Yash, and I'm a third-year data science and cognitive science student at UCSD.
And I'm Anna. I'm a second-year data science major.
All right, so yeah, we're glad to have you here. And what exactly is Pandas? So Pandas is one of the most commonly used packages for data analysis. And since you've probably heard it in your classes. So in DS3 you've used baby pandas, and in later data science classes like DS80, you will be using pandas. So yeah, this is a very practical application that's used heavily by data scientists. And yeah, through practice, you can become an expert at this. And today we're going to go through the basics of dealing with data, cleaning data, and working with data sets. So to get started, yeah, you can download Anaconda, and this has all the packages and takes care of the versions for the packages for you. And you can launch Jupyter Notebooks from here. And that GitHub repository that we linked in the chat has the empty and filled notebooks that you can use to follow along. As I said before, I recommend using the filled notebook since that will help you progress along with the pace. And later on, you could use the empty notebook to complete the practice problems. And yeah. All right, so what exactly is Jupyter Notebook? So Jupyter Notebook, for those of you who have not dealt with Jupyter Notebook yet, it's an execution environment that is cell-based. So you just have different cells and you run the code there. And it allows you to conduct data analysis. And this is very commonly used, and you will be using this, you'll be using Jupyter Notebooks pretty extensively throughout your data science undergraduate experience. And yeah, to create a new notebook, you would just use the new button on the top right and create a new Python notebook. But since we've already downloaded those notebooks from that zip file, you can just click on that notebook title to open it and begin. So now about importing libraries. So importing libraries, we need to make sure that since we're going to be dealing with pandas, we want to make sure that pandas is imported. And NumPy is a numerical package that's also heavily used by data scientists for arrays. And generally the first step when you're working on a data science project is to determine what you will need to import. And in this case, we're going to be using pandas and NumPy. So at the very top of our notebook, we'll have our imports top. And yeah, to run any cell, you could press the run button at the top, or you can just press shift and enter together. And we also use aliases for our packages, and just the convention is to use PD for pandas and NP for NumPy. So import pandas as PD and import NumPy as NP is going to be something that you as a data scientist are going to see very commonly throughout your experience. And now we saw that we did have some data in our folder, and this data set represents movies. So when we want to load a data set, we want to use the pandas read CSV function. So what this does is it will actually convert. It'll read the file path that you give in, and here we gave the movies.csv file path, and it'll take the relative file path based on what you have, and it'll read it into a data frame. So right now we've named that data frame DF, and DF is also a common convention for if you have a data frame, but you can change it to anything you want because it's a variable. And right now we've just displayed the first couple of rows of the movies data set. So now I'm going to hand it over to Anna, who's going to talk more about selecting data and processing data.
Yeah, so here are a few functions that are like common that you could use to manipulate your data frame. So one of them is dataframe.head and dataframe.tail. And so basically these are used to display the first or last few rows of a data frame. So for example, you can pass in like 3, for example, into df.head, and then that will display the first 3 rows of the data frame. And if you pass in 3 into df.tail, it will display the last 3 rows of the data frame. And the default is 5. So if you don't pass in anything, it will just return the five rows. And these 2 functions basically just help you confirm that your data set is loaded successfully and that like all the rows are there. And then to explore your data, you could a really like useful function is to do data frame.shape. So if you run this function, it basically returns the number of rows, a tuple with the number of rows, and then comma the number of columns. And so this in the screenshot below, you could see if you look at the first cell, it's data frame.shape. And so it basically returns the number of rows and then the number of columns. And then another function would be data frame.dtypes. So this basically returns a series with the data types for each of the columns in your data frame. So if you look at the second cell below in the screenshot, if you do df.dtypes, then it basically outputs a series with all the data types for each of the columns. And then there are also a lot of ways to select a column from the data frame if you wish. So in the screenshot below, you could see data frame, and then you have brackets, and then you pass in the title inside the brackets. So this will basically get the entire column that you pass in of the title that you pass in. So this is one way that you could use to select an entire column. And then another way to do the same thing is to just do data frame.title, so without any brackets. And this will basically output the same thing as if you did the first method. And then another way, you guys probably learned this in DS10. This is like, you just do data frame.get title. So this makes it really clear that you're trying to get that column. And so this also outputs the same result as the previous two methods. And then so that was selecting a single column. So if you wanted to select multiple columns, you could pass in the column names within double brackets. So in the screenshot, you can see how it's data frame and then it has double brackets with the title and then with the year. So you could basically pass in multiple column names into the brackets, and that will output the data frame with both columns in it. And then a little bit about the differences between a series versus a data frame. So a series is basically a single list with indices. It's a 1D labeled array, whereas a data frame is a collection of more than one series. So it's a 2D data structure. And so the first screenshot you see here is basically a series. It has a single list with indices. And then the other two screenshots are examples of data frames because they are 2D labeled data structures. And so basically a series is called with a single bracket versus a data frame, which is called with double brackets. And then here are some ways you can select a row. So we went over selecting a column earlier today. And so now this is about selecting a row. So one way you could select a row would be to do data frame.iloc and then bracket 0. So, and this is also equivalent to data frame.loc 0, which is basically selecting the first row in your data frame. And then a little bit more about what .loc, the difference between .loc and .iloc. So .loc basically retrieves the rows and columns based on the label that is passed in. And then .iloc retrieves the columns based on the index or the position that is passed in. So if you look at the screenshots below, if you do data frame.loc, it retrieves the rows and columns based on the label that's passed in. So you can see how it's the first 5 rows. And then if you do data frame.iloc, it's also the first 5 rows, or it's the first 5 rows excluding the number 5. So basically, in simple terms, loc is basically based on the label or the name of the column, whereas iloc is based on the position. And then moving on, we're going to have like a quick practice problem using iloc. So using the iloc method, how would you access the year Avengers Infinity War was released? So for example, you're trying to get the 3rd row and the 4th column. So here are some hints that you could take a quick look at, and you guys can try this yourself in your notebooks. We can give you like 1 or 2 minutes to just work on this for a bit.
Yeah, and if you have any questions about anything, yeah, feel free to let us know. You could type in the chat or you can unmute yourself and ask away.
Okay, so hopefully you guys got a chance to try that out. So moving on, we're gonna go over the solution.
Yeah, does anyone have an answer that they want to share?
Yeah, feel free to type in the chat. If not, we could move on to the solution.
Yeah.
So basically the solution is a screenshot below, data frame.iloc 2, 3. So that will basically give you the answer. And this is because you're trying to get the third row and the fourth column. So if you use zero-based indexing, then that would mean it's getting the second index for the row and then the third column when you're trying to get, or when you're trying to get the fourth column, you would do index 3. And then here's a method that you could use to select multiple rows rather than just a single row. So if you pass the row indices within the brackets, it basically return a data frame that is basically the same as data frame.head. So if you do df.iloc bracket 0:5, it'll basically get the first 5 rows of the data frame. So it goes from 0, 1, 2, 3, 4. And then that will be returned if you run this function. And then another way of doing this would be to just do data frame.lock and then colon or bracket 0:5. So this is equivalent to the previous method. It just has .lock rather than just .iloc. And then the last way that you could also achieve the same data frame would be to just do data frame bracket 0:5. So this would achieve the same thing as the previous two methods. It's just less typing if you enjoy that more. And then we're going to have another quick practice problem that you guys can use to practice selecting multiple rows. So using lock, return the 5th to 10th inclusive rows of the data frame. And you guys can think about how these rows correspond to these indices, and we'll give you 1 to 2 minutes to work on it.
All right. Once you have, if you have any, yeah, if you have any questions, again, just put them in the chat. And if you have an answer, yeah, go ahead and put in the chat anything. Yeah. Okay, so I do see we have a message in the chat. What is,
Yeah. So if you want to try thinking about like the indices of like the last row, the last number you have there, just like double checking.
yeah, the key in Python when you're indexing is to remember that it's zero based. And what that means is your indexing starts from index 0. So when we say 10th row, what index should that correspond to? That's the key. And then, yeah, another thing is knowing that, knowing that it's inclusive of that last one. Those are the two keys to solving this one. But yeah, that was super close. And yeah, someone just messaged me. Yeah, looks good. Okay, so I think we're ready to move on. Yeah, let's go ahead and look at the solutions for this. So,
Yeah, so the solutions, these are like the three different ways that you could have solved this problem. So we asked you to use .lock. So if you look at the first solution, it would be data frame .lock 4:9. And that's because like the 9 is inclusive. So you would go all the way from the 4th to the 9th. And then another solution would be if you didn't use .lock, if you used .iloc, it would be 4 through 10 because the last digit is included if you're using iloc. And then data frame, you could also just directly do the brackets, and then that would also be 4 through 10.
awesome. So now we're going to shift gears a little bit and talk about data cleaning and preparation. So yeah, in data science, oftentimes, or actually most times, the data sets that you deal with are not going to be perfect. So the data sets that you get from classes they often look perfect and they've been pre-cleaned. But in the real world, the data sets that you use will have, they'll have missing values, they'll have inconsistencies within the data, and they'll also have data that is erroneous and that you don't need. So data cleaning is quite an extensive process that takes around 80% of your of a data scientist's time on a project. And it's extremely important to understand the data set because you may be able to correct the values if you know what reasonable values should be like. And before you make an analysis, you should know exactly what the data set is what's trying to portray and what is missing from it and what needs to be cleaned. And there is this saying, garbage in, garbage out, that is that your analysis can only be as good as the data going into it. So if you have data that is garbage or messy, your analysis is gonna reflect the data that was put into this. So your analysis will not be very effective because the data that was given was messy. So data cleaning is a process that is a heavy portion of a data scientist's time, but oftentimes people don't like to do this because it's not as fun as maybe like machine learning or making an algorithm. But this is just as important, if not more, because this can really affect the quality of your analysis. So now we're going to go over some data cleaning techniques. So yeah, the first one is dropping columns. So we have this data set here, the movies data set, and yeah, we have all of these columns. So does anyone notice any columns that seem redundant or aren't helpful? Yeah, if you have any guesses, just go ahead and put it in the chat. Yeah, if anyone can put the name of a column, yeah, the name of any column that I think we can drop and seem irrelevant. Okay, so we have, yeah, the unnamed row. So yeah, the unnamed row, that's one of the that is one of the columns that we'll need to drop. And the reason why this unnamed 0 column comes, you're going to see this a lot later on, but it happens when you export the data. So when you export the data, there's a parameter that you can put, which is whether you export the index or not. And in this case, whoever exported the data kept the index, and that's why when we read it, there are two sets of indices. And let's see. All right. Cool. So some other ones that we have, some other columns that are irrelevant to our analysis are the ID, because we already have an index column. This row in the far left here, that can be used as our index. So we don't need the ID column. And another one that is irrelevant is type, but this one you'd only know if you had checked out the data set and looked at it. But this one is 0 throughout. And yeah, whereas these ones are Booleans. So these ones are ones if it's on that platform, 0 if it's not. So yeah, this one is one that we'd also drop. So now how exactly do we drop columns? So Pandas has a really useful function called drop. And what you can do is you can drop rows or you can drop columns. And this parameter here, this middle parameter, axis, this actually tells you where to do the drop operation. So the default for df.drop is 0, which would drop the rows. And here we want to drop columns, so we would do axis equals 1. And a trick that we learned in class to remember is if you want axis equal, so you can think that columns go up and down is like a 1. So that sort of helps me remember. It's helping distinguish the axes, and yeah, I hope it might help you too. And yeah, so then we pass in a list of columns that we'd want to drop. And yeah, we have unnamed 0, ID, and type. And then this third parameter, in place equals true. We'll see this more in a little bit, but when you do drop, it by default returns a copy. So if we didn't have this in place equals true, the default is false, and it would just return a copy of df. So it would not impact df or edit it. So if you wanted to save it, you would have to have another data frame and say like df2 equals df.drop those columns. But if we do in place, we can just edit that data frame in place and it'll be more space efficient. But some other times, if you want to keep the previous data frame, it makes sense to return a copy. And now we're going to talk about dealing with null values. So yeah, in an imperfect data set, you're going to have a lot of null values. And these are, you'll probably see them as NaN or not a number. And here we can first try using Pandas drop NA function. So if we just use it without all the parameters and we just do df.drop NA, we can see that yeah, we've lost around 13,000 records, and we've only been left with 3,000 rows when we initially had around 17,000. So yeah, we dropped 80% of the data set, which is not smart, and it's not going to help us because we want as much data as possible to have our analysis be as robust. So this is a prime example of why you should really understand your data set, and you should only drop data wisely according to your end goal. So now we're going to try another approach for dropping the column. So we're going to drop columns that were really relevant to our analysis. So here, so first of all, it really depends on the problem that you're trying to answer. But in this first example here, the how parameter, what that means is it's yeah, so it's asking you how you should determine whether to drop a row or not. So here since we said how equals all, we'll only drop a row if all of the values in that row are null or not a number. And in that case, it makes sense to drop those values because you're not going to get much out of that column because all the values are null. And the default for df.drop NA is how equals any, which is why once we did it by default, it dropped majority of the data set, because a lot of the data set it may have just like one empty value. And that's why we really don't want to drop the entire row, because there's still meaningful data in there. So if your problem scenario was to create a distribution of movies comparing the IMDb ratings across streaming platforms, yeah, so you would want to drop anything that was any rows that have a null IMDb rating. And if you have another scenario where you want to make an average of the IMDb and Rotten Tomato ratings for Netflix movies, you would want to drop any columns that have null values in the IMDb and Rotten Tomatoes columns. So you would want to determine which columns are really pertinent to your analysis and then drop rows that are null in that case. And next up, we have renaming columns. So sometimes column names in datasets can be ambiguous. especially if they come from a random system. But yeah, we can easily fix that using pandas. So there are two methods for this, and they have different purposes, but it's great to know both. So the first method is dot rename, and this is much easier if you want to change only a few column names. So in this example, we want to rename the age to age rating because that's a little more clear because these movies have age ratings like it's the MPAA, just like the MPAA rating, like PG-13 or R. And then runtime could be specified to runtime in minutes because that could be more clear. And here, how we rename columns is we pass in a dictionary, and where the keys are the current names and the values are the names that you want to change the columns to. And once again here, it returns a copy, but you can use in place equals true if you want to just change the data frame itself. So in this example, the M1 data frame is going to have the age rating and runtime names, but DF here is not because we didn't do it in place. So it's really your preference. It just depends on the project, but whether you want the changes in place or not. And next up, you can also use the attribute dot columns. So in this example, this is when you would probably want to change multiple column names. And here order matters. So what I recommend is if you do this, you should first type df.columns. So you get all the columns in that data frame already. You can copy it, paste it, and then change you should rename the columns accordingly because the order does matter. And this one is actually an attribute. It's not a function. So you could just do df.columns equals and then put your new list in. And this will affect it in place. So df here will have the changes reflected. Okay, so next up we have data formatting. So right now, if we look at the worst movies or sort from the lowest to highest ratings, the movies with the Rotten Tomatoes rating of 100% would come first. And if you look at the best movies or sort from the highest rating to the lowest, the movies with the 99% would come first. And this is because right now they are strings. So 99% as a string is greater than 100% as a string because it's comparing it bitwise to be when you're comparing strings. So the 9 is greater than the 1. But that's not exactly what is intuitive because when you look at numbers, 100 is going to be greater than 99. So if we want to sort by ratings, which is likely what we want to do in a movie data set, we should fix this and we should format the data so that the Rotten Tomatoes ratings are numeric values. So what we can do here is in that first line, we have stripped all of the percentages because initially it said like 87%. So we can access the string attributes and strip that percentage. And then we can save that as an intermediary step right here. And then we can use Pandas handy tool to convert a string to a numeric by using the pd.toNumeric function and then inputting that series in there or that column in there. And finally, you'll see that the Rotten Tomatoes column has only numeric values. So now they're floats. So before it would say like 95% as a string, but then it would say 95.0, which makes it easier for analysis since now we can sort it and take averages and pretty much do logical things with numbers that you wouldn't be able to do with a string. All right, now moving on to conditionals. So conditionals are something that you've probably seen in math, and they're pretty much common across programming languages. So conditionals in Pandas is especially helpful for filtering out your data frame and including the information that you really want. And the comparison operators are the same as the ones from different languages. The one to be careful for is the equals. Like in other programming languages, if you want to check for equality, you need the double equals because a single equals stands for assignment, and then the double equals is for checking for equality. And something different that you'll need to be using in when you're making comparisons is the bitwise operators. So when you want to combine the comparisons, which you'll see in a bit, you will want to use the ampersand for the and the pipe, which is above the return key for the or comparisons. And yeah, now for an example of filtering out your data set. If we wanted to filter out the movies data set to include only Disney Plus movies, we'd first determine how do we know if a movie is on Disney Plus? So we look at the Disney Plus column, and you know if a movie is on Disney Plus if the value is equal to 1. So we'll first make a Boolean series, and what that means is it's a series where each value is a Boolean, so true or false. And we make that Boolean series by saying that column value equals 1. So is it equal to 1? And then it'll give you a bunch of true or falses based on whether that row value was equal to 1. So yeah, so in this case, we can see these bottom ones were offered on Disney Plus. And then something really cool that we can do is we can actually input this Boolean series into here and query it from that data frame. So you can query the Boolean series, and what that will do is it'll actually filter your data set, and it'll include only your area, the area that you want to see. So as you can see here, in this Disney data frame, all of the Disney values are 1, which means that we've correctly filtered the movies data set to only include the Disney Plus movies. And when you talk about strings, strings are a little bit more complicated because strings can contain substrings. So if you want to look at the genre category, if you wanted action movies, we couldn't just say that the genre is equal to action, because here it's a string, and although it says action comma adventure, that's not equal to action, even though it contains action. So we need to use a handy function called .str.contains. So we do the .str because it will access the string attributes of each of the values within the column. And then we'd use the .contains to search for that substring that we want. So if we wanted to find all the movies that were directed by Steven Spielberg and were family movies or action movies, this is like a pretty complex this is a very complex conditional, and we could probably use multiple steps to filter out the data frame. So our first step here would be to determine all the movies that are directed by Steven Spielberg. So we can use multiple steps here because it's a lot easier. So our first we can make a series called director, and that is a Boolean series that depends on whether it contains Steven Spielberg. So we take that column and access the string attributes. So we do .str and check whether it contains Steven Spielberg. And that would look at this directors column right here. And next up, we want to see whether a movie was in the family category. So here we just, here we'd do something similar. We'd access the genres category, the genres column, and check whether it contains family. And same thing for action. And now is where the fun part happens. This is where you combine all the comparisons, all the conditionals to filter out your data frame to include only what you want. So here, what we're doing is, we're combining all of these Boolean series to sort of reflect what we want. So we want movies that were directed by Steven Spielberg and were either family movies or action movies. So here, what we've done is we've shown that we want where the director is Steven Spielberg, and which is why we have the ampersand, and then we want either family movies or action movies. And since we want an or here, that's why we have the pipe. So what this will do is it'll see whether it was either in the family category or the action category, and then it must have Steven Spielberg in it. And then we're querying it from the original data frame, which is why it'll filter it. And then the bottom is what we did at the top, but condensed into one line. But I personally don't recommend doing it that way, since it's a lot more confusing and it's not as readable. And if you're debugging your own code, it makes it really a hassle to figure out what you've done wrong. So I always prefer using intermediary variables. I think that's the easiest way to code. And if someone's looking at your code, it's much neater. And if you're looking at your own code in the future, it's also a lot easier. But yeah, in this data frame, we can see that the filtered ones have Steven Spielberg as the director, and they either have action or family. It could also have both, but we just have our conditional so that it should either have family or action. All right, so next up, we're going to do a practice problem with conditionals. And so this one is, it's similar to the previous one. It has a bunch of conditionals that you will want to use to filter out your data frame. So yeah, you're holding a club social virtually through Netflix party, and all of your members are adults. So you'd like to choose a movie that is suitable for 16 plus or 18 plus, and this is the age rating. And you want to watch a comedy movie that came out sometime between 2000 and 2016, inclusive. And then you don't have high expectations, so anything rated above a 5.5 on IMDb is perfect for you. So your task is to create a social data frame, so a data frame named social, that has all the possible movies that you can watch. So yeah, this is a bit of a tricky problem. But yeah, give it a shot. We'll give you a couple of minutes, maybe like 3-4 minutes to check it out. And yeah, if you have any questions about anything, yeah, feel free to let us know. But yeah, give this problem your best shot. Okay, does anyone have any progress or anything that they want to share? Okay, I think I will, yeah, I'll just go ahead and show the solution and I'll walk through it with everyone. So yeah, so the first thing, the first thing was we wanted a movie that was on Netflix. So our Boolean series would just check whether the movie is on Netflix, and we do that by checking whether the value is 1. And then what we wanted to see was whether the age rating is either 16 plus or 18 plus. So what we did here was we access the string attributes within those columns, and we check whether it contains 16 plus or 18 plus. And the reason why we did an or here, not an and, is because if you did an and, it would not select anything because a movie is not going to be in both categories. It will be just in one category. And we were fine with either one, which is why we chose an or. And we want to watch a comedy movie, which is why we wanted the genre to have just comedy, to contain comedy. And then we want a movie from 2016 at the latest, so 2000 to 2016 and inclusive. So that means it includes both 2000 and 2016, which is why we use the less than and equals to, or greater than equals to, and less than equals to. And the reason why we use and here is because we want movies that are within that range. So if you think of a number line, we want stuff that's between that. And then we wanted ratings with movies with a rating of IMDb above 5.5, which is why we take that IMDb column. We look for values that are above 5.5, and then we put it all together. So we wanted to put all of that together, and here we just say and for all of them because we already did the or part here for the ages and the and part here. So yeah, here we sort of broke it into categories kind of neatly to yeah, we broke it into categories. So this one is the whether it's on Netflix party, this one is the ages we want, this one's the genre, this is the year range. So yeah, the last part is the easy part. That's just where you put it all together. And yeah, you'll end up with 108 possible options, and at the top you have silver linings playbook. And once again, you could do this in one line. And this is an example of, and this is one where I totally recommend you not to do it in one line because it's just so confusing. And honestly, like I can't even read it. The way that I wrote this was by copying everything from up there into there. So yeah, this is an example of why breaking it apart into pieces is just better programming. All right, so now we're going to shift gears a little bit and talk about sorting. So yeah, sorting is going to be something that you use oftentimes if you want to find the most or least values for something. And this is going to be a very common approach that you use in data science. So let's say that we wanted to find the worst movies. So we'd sort ascending, which means lowest to highest for Rotten Tomatoes. And we could do that. We could also find the best movies by ascending, by saying ascending equals false. So that means we're going from the highest rating to the lowest rating. So sorting a single column is generally it's pretty standard. Once you get in the practice of it, you'll find it pretty simple because it's the same every time. You just give a column and then you tell it whether it's ascending or descending. But then it gets a little more complex when you're sorting multiple columns. But it's nothing, yeah, it's nothing to be worried about. When you have multiple columns, it's honestly pretty similar. The only difference is that you'll be passing a list to the by parameter. So in the previous case, when you're sorting a single column, you just give it a column, just give it a string. But when you want to do multiple columns, you just pass in a list, and then you would say by equals. So you're sorting by that list. And what it does is it will sort first based on the Rotten Tomatoes, and then it'll sort based on the IMDb if there's a tie. And then here we have ascending equals false, which means it'll be sorting descending for both Rotten Tomatoes and IMDb. So yeah, what if we wanted to sort columns in different directions? So yeah, like this would be like if we wanted to find critically acclaimed classics. So we wanted the best movies. So we want to say the Rotten Tomatoes is descending because we want movies from best rating to worst. And if we want classics, this means these are the old movies. We'd want the movies that have the earliest year and all the way to the newest one. So this is yeah, this can be solved by passing a list to the ascending parameter. So what we can do here is yeah, we can have the list for the ascending parameter, and it corresponds like whichever one you the order corresponds to the column. So we have Rotten Tomatoes here. This is index 0 in this list, so it'll match index 0 in that list. So we'll be sorting Rotten Tomatoes descending in descending order, and then we'll be sorting year in ascending order. And yeah, these lists have to match in the size, otherwise it's going to give you an error because it needs to know how to sort them. So if you don't have the same list length, it's going to give you an error. Okay, so now we're going to do a quick practice problem in sorting. And yeah, I'll give you a couple of minutes for this. And yeah, this will be our very last thing for our workshop. So I'll give you a couple of minutes for this. And if you have any questions for anything, yeah, feel free to let us know. So yeah, in this case, yeah, you'll be using the social data frame, and yeah, there's still too many movies. And since all 108 movies fit your criteria, you want to find the movies with the best Rotten Tomatoes ratings and IMDb ratings in that order. So yeah, so then you would want to create a social sorted data frame that has these top movies from the social data frame. And then you want to find the top 10 movies that your club can vote on. Yeah. So this one's a bit more complex and incorporates multiple things that we learned from this workshop. So yeah, give it your best shot, but yeah, no worries if it takes some time to understand it. All right. Does anyone have any approach that they have or anything that they're thinking? Yeah, feel free to unmute yourself or type anything in the chat. All right, let me just move on to the solution. So yeah, this one has a couple more steps than before. So sorting was just the very first step, and then slicing was a little bit more difficult in this case. So we'll go step by step. So yeah, so we first want to sort based on the best Rotten Tomatoes and IMDb movings in that order. And we already did this example, but yeah, we want to sort first by Rotten Tomatoes and then IMDb. And we wanted to name the social sorted. So that's why we don't do it in place. We want to save that copy into social sorted. So then we can just do dot head, and we can also put in 10 here. The default is 5, but you can always change that. You can put 10, and it'll show you the first 10 rows. And now what we want to do is slice. So we could try slicing. And here, if you want to use dot lock and get the titles, it gives you an error. But that error is because it's telling you that index must be monotonic, increasing or decreasing. And what that means here is that these indices have to be like consecutive. And here, when you look at this, the indices are actually not 0 to 9. They're just random indices because we've sorted the data frame. So their indices are out of order. So now we can do some problem solving and shift gears. So what we can do is reset the index for slicing. So what we can do is do dot reset index, and then we could do drop equals true because we don't want an extra copy of the index. And then we could do in place equals true if we want to do it in place. And now we can do the exact same thing we tried. And yeah, we would just do sorted dot lock 0 to 9 since 9 is included, and we want the title column. But if you wanted to avoid that hassle of dropping the index, what you could do is just you could just do iloc, which is positional based. So in this case, iloc is much easier because it's positional based. So you would just get the first 10 columns based on the position that they are right now, not based on their index. So yeah, those are some techniques, and thank you so much for coming to our introduction to pandas, and we hope you learned something new. And yeah, if you have any questions about anything, feel free to reach out to us. And yeah, this recording is going to be available on YouTube if you want to refer back to it. But thank you for your time, and yeah, I hope you have a great night.